audible or not, because last time it seems like we are not audible. Just check and confirm. Yeah. Hello. Are you audible? Uh, let's see this. I don't think so. No, let's just check. Is it audible? My question 1 2 1 2. Check. Let's wait for a few seconds. Okay, now I have raised the voice also. Let's just check. Is it audible or not? I have to wait for. Okay, we got it. And now we are good to begin. Let's start. Let's start with a new session actually. So we are not. We have taken a 2 day break, so no issue. We have been enough time. Let's continue with the practice sessions and let's start with the new questions. Just a second. I need. Okay. Yeah. Safari. This is a Safari. Let's have a chat GPT. At diagram. Software engineering. Software engineering. So let's and guide is engineering to become to develop skill in system design and understand its various concepts. We are practicing. We are practicing uh, problems, coding programming problem, uh, statement, and uh, problem statement, and let's continue on that. Let's continue with that with that with the new questions. Yeah. So let's start. Before that, let's have a question here. So since state management, okay, what we have been auto control, right? So we have been completing the last auto complete. Let's move forward further with the new questions. Mm, let's give this thing the multi-select drop down. This has been completed, right? Now let's okay. Mm, let's give this data here. But where were we? Multi-select drop down is completed, I think so. Keyboard auto compiler. Keyboard notification is also complete, and we will be moving forward with the phase 3 async JavaScript. Okay, let's just start from this the new session. So we'll having a new context. Below I have uh, pasted the Basically the context from the previous session. Go through with, go through with. Let's have a context here. Text. Okay, this is the context. In last session, we have completed the auto complete. What we have been completed last time? Let me check. We have been completed keyword navigation. Okay. Autocomplete keyboard navigation. Let's further. Okay. So let's move on. Okay. We work on okay. Hi, Sal. Welcome back to our session. Currently, I'm working, you can say. I'm not going to college anymore. I've chosen to try to give myself as a work, and so let's prepare. I'm preparing for the new job. Currently working as an intern, you can expect that. And yeah, let's start. So here we are practicing more, and so we can grasp the skills about the system design and other thing. So improving that, so we can crack a okay. Mm, I don't know what's the issue with this. Hello, hello. Mic testing one two. Hello, is it audible? Is I think so. It's been audible. Let's get back to the here. Here. You can have your understanding, and you can also share all the things that you have been doing still now. What are the questions you have been solved? What pace you are learning, and where are you standing right now? How the daily you are figuring out your questions. So like this, you can track and ask. I don't know what just happened, but let's change the thing here. And I don't know what just happened, but there is a issue kind of. Just I don't know what just happened, but let's change the thing here. Yeah, now it's fine, I think so. Let's continue. Hello? Just happening. I think now it's will be audible. Can you just confirm? Uh, if you're there, hi, Sai. Yeah. Okay, so we are talking about you can take the help of the AI. So you can go to the chat GPT and ask him to give me a data which I can follow as a journey map for the per week. So give me certain tasks which I achieve daily, and I can also track my records. So you can solve the daily problems rather than giving a whole things of whole month journey, which will be frustrating also, and you will not be able to track yourself, and must try to solve the different version of the data, different versions of the question, not just like a okay, this has the same thing, same questions repeating. Try to doing the different versions of that, so it will be help you. Okay, let's continue with the question, back to question. So today we are practicing in the system design question. We have a move forward in the phase 3, and in the phase 3 we are introducing the async autocomplete. So till now we have been practicing this async autocomplete, which is like a search bar. Here we try to search something, so you can see apple. So it is a synchronized way. Now we are trying to do in asynchronous way. So which means it will be having some API or third party API. Let's see in the question itself. Okay, let's rather than seeing here, let's copy this and paste here. Okay, we are having this thing, text file, and let's paste here. So we have this data for now here. Okay, and here we are. So let's see what we have questions today. Absolutely, since we have been completed autocomplete plus keyboard navigation, the next step should be asynchronous autocomplete. Okay, so there is a very important jump from we move from UI reacts to local data to UI reacts to asynchronous external data where responses may arrive out of order. That introduce the real world system design thinking. Okay. Next problem is async autocomplete with race condition handling. Okay. So now we are going to handling some race condition. Let's see how it's working. So let me check the charging first. Okay, it's okay. Let's me off this charging first, and let's begin with the question. So we are having a question: autocomplete search component, where suggestions are fetched asynchronously from a server. Okay, so we are most probably trying to request some third-party API integrations. So let's just see. User types a API request. Okay, yeah, you can see API request. We are using the API request here. So server response unexpected order, app response in 1000 a and 5. Oh, okay, 100 ms means 0 point something, because 1000 second 1000 ms means 1 second. This is a point 5, point 3, point 1 second. If you blindly render every response, the UI could end up showing suggestions for a even through the user has already typed app. Your component must prevent stale response from updating the UI requirement. Input search. Okay, there is an input search. So we will continue with this code only. We will not modify not start from scratch today. We will try to modify in itself, so we can save our time instead of building all the things from scratch. Okay, so input. Okay, that's great. Fetch suggestion app. Okay, calling the fetch suggestion app, assume the functions already exist with a return a promise. Okay, so there will be a promise. We are not using a third party API for now. We are try to giving user the promises. Okay, so we will try to create this also. Yeah, that will the new thing. Not the new thing, just having a new practice in there. Loading states, okay, while waiting, searching should be displayed. Suggestions, when the request successed, apple juice pineapple should be displayed. Okay, like you are calling from a server, it sends a API request, so it's again sends the response. Okay. Empty state, if there are no results, no result found. Error state, if the API fails, something went wrong, try again. Okay. Keyword navigations already implemented, yes, previous problem, continue supporting. So yeah, we will not be working in here from scratch. Important requirement, handle stale response, consider user types A, request A, user types AP. Oh, so so you can see here the multiple requests are just sending when we are changing just a alphabet. When you type say A, so request will be going like A. The request A will contain only A, and when the user type is AP, so the request B will be sent with this data. So every changes will hit API. Okay. So the response from A not override the result of B. Okay, A must not override the result of B. Okay, so here we have to understand how we are going to figure this out also. Okay, let me check once again. Is it audible or not? The response from A. Okay, is it audible? Or broken again? I don't know what just happening. It's again stopped, I think so. Right? Is it audible? I don't know what just happening, but somehow our voice is going for sometimes. Okay, let's just concentrate it back again. We'll try to fix this out. What we will be issues we will be looking into out. And then before the next sessions, let's just continue with the session. Okay, yeah, let's move forward. So we have a constraints. We have. Okay, let's intentionally keep the problem focused. You should not implement this yet. Debouncing, okay, catching, paginations, infinite scroll, about control. You should not implement this yet. You should not implement this yet. Okay, we'll introduce those separately. Okay, this will be uh, introduced in the separately. Let's go step by step. Now focus on input state, async request, raise condition handling, and render. Okay, your first task, don't code yet. As a senior engineer, I don't want you to immediately start writing with JavaScript. Okay, Mm, that's the thing. Okay, let me just check again the voice. State async. Yeah, it's audible. Okay, let's continue. As you see, okay, just a second. Yeah, I think so. Voice is audible now. I'll just check and continue again. Waiting for a second. I don't know what just happening. Our live sessions uh quality is Just check and continue. Waiting for a second. Yeah, it's working. Don't know what just happening, but our quality is not like previous and flow was good. Okay, no issue. Let's just continue. Your first task, don't code yet. Okay, as your senior engineers, I don't want you to immediately start writing JavaScript. Okay, the first design the state. Think about question one. What state does the component actually need? For example, you might think about query, suggestions, loading, error, index, active index. Okay, but don't blindly copy this. Ask yourself, what information does the UI need to know in order to render every possible state? Okay. Okay. Question number two is, how will you identify a stale request? Okay. Suppose a request of one finishes last. How can code determine? Okay, these are the actually next level questions that we aren't expecting this things. Okay, let's just understand this all the questions. How we are going to understand all of this? Okay. Mm, During the rainy season also it is becoming hot actually, and the raining has been stopped. Don't know. We don't know actually how the weather will be in future. Previously, it will be in the previous in our childhoods. We can see we are having at least 4 months of raining, right? But now it's been less. Actually, 3 months has already passed. Not exactly 3 months, 2 month, and it will be soon in the half also. So 2.5 month. Okay, let's focus into the question. The question is, how will you identify a stale request? Okay, so for example, request A, request B, okay, request A. Suppose the request one finishes last. How will you, or how can the code determines this response should belongs to an old request? Ignore it. There are several possible designs. We will discuss them after you propose one. Okay. There are the multiple design pattern, and we didn't aware, I didn't know about it, and also not aware about those pattern. So we have to research and understand what are the different patterns and how we are going to figure those out. Question 3. Draw the state transition, something like user types, update query, start request, loading true, success, failure, suggestion, error, render. But now add the race conditions. Okay. Your assignment before writing implementations code, send me. Okay. Before writing implementation code, send me state how well. Okay. So now we don't have to code. We have to figure it out how this will be looking. So now we are trying to create a critical thinking level. So let's give the answer first and then we try to code. Okay. So let's use our thinking and understanding. Okay. So what are the different questions? Let's see. Okay. So these are the requirements. Let's go through again. Interface style program statement. Build an auto search component where suggestions fetch asynchronous from the server. Okay. User A types A API request. So see, A user types A. So A will be just a request the API, and if AP types again the P, then it is a continuous. But it will be also a different request, not the same request modifying. It's a calling a different request. It is a different request. Mhm. If you blindly render every response, the UI could end up showing suggestions for A even through the user had already typed APP. Your component must prevent stale response from the updating UI. This is the latest and the newest thing that we are going to practice, and we are not aware of it, how we are going to deal with this. Okay. So how your component must prevent the stale from the response updating UI. Okay. We don't know actually. Let's figure it out. Requirement search input. Okay. Fetch suggestion. Loading state. Okay. What are the question actually? So these are the question. Uh, What state does this component actually need? For example, you might think about query, suggestion, loading, error, active index, but don't blindly copy this. Okay, let's figure this out how we are going to see this. What state does this? Okay, let's figure this out. What information does UI need to know in order to render every possible state? What information does the UI need to know in order to render every possible state? Every possible state. Okay. What state does the component actually need? Component needs actually okay. Question is simple. Agent is asking us what state, okay, does this component actually need? We are maintaining a state. In the previous state, we are maintaining query and is open. Okay, this is the two thing we are trying to maintaining there. But now we are having multiple things to understand. Let's see how we are going to manage this. For example, you might think about query suggestions. Okay, so see, there is a multiple things. Okay, we got to know. First thing is the state. We are surely going to manage this thing state. And apart from this, what will I having? Oh, sorry. Let me have is query. We will having is query. Okay. So this is the one thing we are going to have. What we will else have? We will have a suggestions. Mm, what information does UI need to know in order to render the every possible state? How it going to list out all the possible state? We are not know about actually. Let's move further. Okay, let's understand important requirement. Handle the stale response. User types A request A. User types AP request B. Response A not overwrite the results of B. Okay, constraint. Intentionally keep the problem focused, should not implemented. Okay, this should be not implemented. Mm, still little bit confused, but let's figure it out. Is there will be have a loading? Yeah, it will be having a loading state because when we call the API, so it needs certain kind of a timing. Okay, for having a skeleton part and loading part. Okay. Mm, so when I type a request will go, which one will load, and it will become hit an API. Okay, so what is a path actually? Level take a help of escalator. Mm, so this we are having API. API. Okay, we have this API, and this API will be hit a server. We are have a server here. We are having server here. Okay, so this is a server, and we are trying to hit with API. When user types something, it will be hit a user. Okay, and what will be in the screen will be changes. This is a screen, screen screen. Okay, we are having certain lines. So the user types a, so it hit an API. If a user tries to a p, it will hit again. Okay, so if we're typing this, your request will be going. So this is a request. So if it is a request, then here something print, here something dot like something will be happening, loading the state. Okay, so we need to do this thing. Okay. Uh, Question: what state does come in actual? Okay, so this loading is means timing will be loading something tracker we need. So it will be loading showing. Okay, it's query, so it has the data of tracking this also. Query will be, and loading also will be there. So apart from this, suggestion and active index, do we have active index here as a tracker? Yeah, we have a tracker here actually. So instead of a tracker, we can have an active index. So that is okay, possible that we are having active index also. So for now, let's make the little thing simpler. We will be having this state as a state as this thing. Okay. And what question we will having a two? How will you identify a stale request? Yeah, this is a interesting question that how we are going to identify a stale request. For example, request 1 is A, request 2 is AP, and request 3 is app. Okay, so how we are going to figure this out? So there is a issue that we have to, okay, suppose request 1 finishes last. So how we are going to capture those? How can the code determine the response belongs to an old request? Ignore it. The server are there are several possible designs. Okay, let me think. How we are going to do this thing? Figure this out. Mm, 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 mm. We are sending a request and a AP and A. So suppose it's like we send it this ascending thing and we get the descending one. So we can send something along with this. Okay. The question one is this, and the question two will be we we will try to send some ID or anything in request which helps to identify the request response request response. Okay, let's see, let's move with the next questions and let's see what will we having. The question 3 is draw a state transition, like something user types, update the query, start request, loading true, success, failure, suggestions, error, render. Okay, so this is the thing that we love to do because this is the actual system design. Here, before coding, before anything, you think in your mind and in the pen and you get a pen and paper and draw the things like how the system will be flow, how the water cycle will be flow. So there are cycles, life cycle will be flow actually, not a water cycle. Water cycle is a type of a life cycle. Waterfall life cycle. Yeah, waterfall life cycle is something. Let's stay away from that. Let's have okay. So I think this is a okay. Let's have this user types. What happened after that? When user types, you update a query. Okay, that's fine. Let's have this flow. Correct. Okay. User types update query and start request. Okay, loading time true. But how we are going to figure out the stale thing? That is a more important here. And here we are having a send start request. Okay, uh, success error. Okay. Mm. User types update query start request loading. But now add the race condition. Race condition is when a user types A and B, you can say if this thing, how we are going to manage this thing. The issue is here. Okay, let's bring this thing here. We have to figure it out how we are going to handle the stale thing here with the race condition. This is a stale thingy, only the this is the race condition. User types update query After that, it's happening the loading true, and we have a two path. That's one is a success, one is a failure, and it's happening like this thing: suggestion, error, and render. So let's have this flow first, and then we try to modify it according to our thinking. Okay, so let's plan this out first. We are having this thing, and then now we are having this. Now we are going to have this thing. Okay? But how? User types, update query, start request, loading true, success, failure, suggestions, error, and render. Mm, but if you types p, so again there is update query and start request, and again the three from. We can't have this multiple thing, right? So what we can do is, I'm thinking about when a user types something, so we will be going to wait for some time, like half second or 1 second before sending a request. If user is updating a query like in the half second, in a 1 or a 1 second, so we will be update that query, and then we are going to hit a target. Okay. So what we can do, we can create either temporary holder, temporary holder, okay, for few seconds. We are going to have this temporary holder for few seconds. So let's plan this thing. So we will having this thing and update query, and flow will be like this, going to hold for few seconds, and then we are going to have a start request. Let's have this thing here, and then we are going to have a start request, and then loading true, success will be work. Okay, so we are having a temporary holder here. Okay, can we copy this thing actually? uh, let's this have, okay, uh, let's bring this here so we can copy this here, and let's have this thing here, also this here, also. mm, okay, let's now bring this here. Yeah, uh, let's bring this thing whole here. Okay, can we copy this? Let me check if it is possible or not. Okay, we are having our answer here. No, 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 that's a bad idea. This is a flow which are we thinking about it. Okay, for now this is our system design. mm, okay, state transitions, example race condition, one example race condition, state transition. So we will having this thing actually. mm, mm, mm. Uh, mm, mm, mm. Let's submit this thing actually. So let's see what is the thing we can get. Okay, where is the Safari here? Do we have, okay, so we have our suggestion. Let's have answer. Mm, this is the answer. Okay, so we are thinking to have a temporary space, and it will hit after 0.5 or 1 second the query typed by user. Okay, let's understand and think. Let's see how the AI will figure this out. Good start. your flow is mostly correct. Okay, so we got a correct. And I like to like that you draw the state transition before coding. That's exactly the habit I want to develop. Okay, we will be understanding, and yeah, we will try to maintain some this kind of flow first, and after that we are going to work on coding. Okay, so let's plan first. Your state is missing some important information. You propose is query loading active index. I would change into query suggestion false. Okay, loading false, error null. And okay, so exact thing they have been pasted. Why? Think from the UI perspective. The UI needs to answer what should I render now. It should know what did the user type. Okay, what result do I have. Okay, I am waiting, loading. Okay, it is something fail, error, and result is highlighted active index. Okay, got it. Isn't useful. We already use query. Query equals to app, for example. Okay, okay, got it. Don't store information that can be derived from the existing state. Okay, is query is it true? We already have a query. We don't know. Okay, okay, so it's wrongly created. Okay, no issue. Temporary space idea is actually debouncing. Okay, so what we planned, we try to as a temporary space, and this is a idea which we call actually debouncing. This is called debouncing thing. Okay, we got to introduce with debouncing now. We will have a temporary space and it will hit after 0 or 1 second the query user by type. Excellent observation. But this is a different problem from the race condition. We actually current solving what you describing it. User types wait for 0 0.5 second. If user hasn't type, again make the request. Okay, this is called debouncing. Okay, so this actually this is a method, what we can, this is a concept. This is a concept which called debouncing. This thing that we described above. Okay, but this is a not exact solution that we are looking for it. Okay, let's see. For example, user types ap and app. Okay, 1 2 3 4 5. Okay, unnecessary, it will be like taking a 0 0.5 second. Okay, instead of app apple, okay, we make api apple. Very useful, but we are intentionally not implement debouncing. Okay, we are not intentionally implementing the debouncing yet. Okay, next step, it is a the race condition is different. Okay, imagine we have no debounce at all. Okay, now we are not having any debounce. Okay, we can't use the timer thing, that temporary space or a timer for now. Got it. If user types a, request a, got query a, immediately ap request to ap. Okay, this is a race condition that we are having now. Then app, okay, request 3 app. Okay, now imagine, okay, 100 200 500. Okay, this is a, okay, now response. Okay, the correct flow is 3 response. Okay, render app result, and this should be ignored. Why? Because app is the current latest query. Your idea is exactly the right directions. Okay, got it. You send some id or anything in request which helps to identify the request response. Yes, this is a concept I want to discover. Okay, so we have a certain things correct also. So we are going in the right direction of thinking and creating the critical think understanding to system design questions and other questions problem statement. So that is a growth sign that we see here. Yes, this is a concept I want to discover. Just check. Yeah, audio is audible. That's fine. We have to check every time because last time the whole video has been push problem statement has been solved, but we didn't record any audio. That was a very bad thing that happened. No issue. Happens sometime. Your idea is sorry. Your idea. Okay, little bit confusing. Your idea is exactly the right direction. Okay, what is a concept? Let's see. We can maintain something like let request id equals to 0 every time we start a request id plus plus. Okay, this is the id 1, this is id 2, request id 2, request id 3. Where the response comes back, we check id equals to request id stale response return. Okay, if the id is not matching with this, it is a stale response, then it will be return. Imagine request 1 response arrive, current request is id 3, and if it is not meeting, it will be ignore. Oh, that's a new thing that we discovered today, understood today. Okay, request 3 response. Okay, current id request. This is our first race condition solutions improvement to your flow. Current diagram currently says user types update URI start loading. Okay, that's good. I will make it more explicit. Types query update, create request ID, loading true, API request success failure. Is the current request ID current? Is the current request ID? Yes or no? Render, ignore, error, ignore. Okay, got it. Notice something important. The stale response check applies to both success and failure. Okay. Suppose a hashtag a sorry, which means ID a and request. Okay. A fails and request to succeed. Okay. We also don't want request one errors to overwrite our current UI. Okay, that's a great thing that we are going to do. So your current design is, I would score your 7.5 to 10 of 10. Oh, so in a system design, we are getting a score of 7.5. That is a huge growth and understanding that we are developing from our past few sessions. So yeah, we are improving. Let's move further. You are correctly identify the async request, loading state, success failure, state transaction, request identifications, the need of delay request. The main thing is to separate race conditions and debouncing. So there is a two different concept that we are discussing. Debouncing is a totally different concept, which we try to figure it out with the extra space, also with certain little time. That was a concept of little debouncing, and here we are facing the race condition, which is a way separate thing. Which response is allowed to update my UI? Debouncing, when should I actually send the request? This is the debouncing thing, and this is a race condition. Okay, so we understood the difference between them. Your next task, don't code yet. Okay, modify your answer and give me this three thing: final state. Okay, right. Race condition mechanism. Okay, explain in your own word how this is work. Okay. For example, okay, user types A response. Okay, tell me the difference in your own words. Okay, so I think we are having little theoretical part, something like that, uh, rather than practical solution. Okay, that's also great thing. Let's go like this only flow. Let's give the hand over to AI. So he will be teaching us in the way more better thing. So let me copy this thing. Okay, and let's give him an answer. So we are having this thing. We have this question here. We're not supposed to do here. Instead of that, let's copy this the whole thing and update this. This is a untitled 4, right? Yeah. Your assignment. Okay, let's have this here. We have created a pattern so we can understood. Okay, so this is understood. Okay, it is a breakdown. Let's have a answer here. Okay, so what is the questions we are having? We are having a final state, right? So yeah, we are good to go with, rather than is query, we are having a query, we are having a suggestion, which will having a array. Okay, apart from this, what we are having else? What have been guided by AI? We are having query, suggestion, loading, active index. Along with the loading, we are also having a error. Okay, we are error loading, and yeah, this all the things we are going to have it. Okay, nice to have it. Okay, let's see the questions too, what we are having. So this is a question number 1 answer we try to give, and race condition mechanism. So let's elaborate more about this. elaborate. I don't know what just happened, but the key B tab is not working fine actually. Uh, elaborate. Okay, so we are elaborating a solution. What we are going to have here is uh, we will use a tracker, request tracker, request tracker ID tracker instead of tracker or something, request ID tracker, okay, which will check the current request ID as well as the current response ID. Okay, if those are same, then we are going to compare the we will compare the answer. If those both are the same ID, we will be having those thing as answer. Okay, storing as answer. We will compare those answer, compare those ID. If it's same, we will store and show it. Okay, if not, then we will ignore it. Okay, so that's the thing we are going to do. Okay, now let me tell me the difference race condition and debouncing. Okay, we are having a theoretical class here, I think so. Race condition was, what is the race conditions was handling multiple request with the user typing and the request firing the multiple request and getting multiple request with response also. Okay, this is the issue that we are facing. So let's move. Other than this is debouncing. Debouncing is about, what we're going to say is uh, base condition was debouncing was wait for you for some time so we can hit uh, with the proper data that user desire. Okay, I think that's a normal and good answer that we can give to AI. Let's give the AI and start for. Okay, okay, here answer. Let's for the with implementation of code. Okay, so we have passed our solutions understanding that we are having to the AI, and exactly your mental code is now correct. One small terminology improvement: race condition isn't a specific multiple request, it's when the multiple asynchronous operations can complete in an unexpected order and produce an incorrect final state. Now, let's implement incrementally. Don't jump to direct polish solutions. I want you to see this piece, Will. Mm-hmm. Mm, 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 mm. We are having a certain kind of a data here. Okay, so we will be starting from this. Okay, so we are having a fresh data, right? Okay, so you have to just then, okay, this is a, like fill in the blanks. We have to fill the data, and we are not creating a scratch from this system here. Okay, so it's like a question paper. That's an interesting thing. Okay, where does the data gone? I don't know. Okay, let's just copy for safer side, because I think we are facing some kind of a lag issue here. I don't know. Mm, okay, here we are having again this thing. So it's easy to identify. Okay. Let's have a data here. So we are starting with a question. Let's see. Okay. Okay. Fake API. So let's go through this first of all. Exactly, your mental mode is now correct. Okay, that's great. Small terminology improvement. Race condition isn't a specific multiple request. It's when multiple asynchronous operations can complete in an unexpected order and produce the incorrect final state. Yeah, that's the thing. And great thing, whenever we hit a API for getting a response, we request a API to the server, so it might be take little more time, and it can give a response, a delay response. So we can't assume that the response that we get from the server, it is actually the response that we are asked for. Okay. Step one is we have a basic HTML code. Okay, and this is a flow. Our UI has a three responsibility: input, status, and suggestions. This is the three UI responsibility we are having. Step two is about the state. Okay, we are having a state. This is now notice something. We are not storing request ID inside the UI state. Why? Because request ID isn't something the UI needs to render. Okay, that's a great thing to remember. Is async controllable variable. Okay, request ID. Yeah, this distinction is useful. State, what should the user see? Request ID, which async operation is allowed to update the state. Okay. Fake API. So instead of using a third party API, we are trying to create a fake API here. So since we don't have a real backend, let's simulate one. So here we are understanding that also, how we are going to simulate a uh, fake API. Okay, so we are having a fruits, and this is a fetch suggestions query. Return new promise, resolve, okay, delay, max dot random, set timeout. Okay, so we understood this because we have been practicing this thing promise and other of the concept of asynchronous JavaScript and other OOPS concept we are practicing from our live sessions. So we easy to understand what is the code written here. Okay, now every request take a random amount of time, that intentionals. It lets us reproduce. Okay, yeah, this is exactly what causes our race condition problem. Yeah, got it. Step 4 is import event. Let's connect the import. Let const input document dot query select a search input. Okay. Well, they have given a huge hint for now in today's session. Okay. Start a request now. Create a new request ID. Mm, Are they gave the solution itself? Handle the response. Now comes the important part. Mm, mm, mm. Isn't it the solution? I think so. They have given the solution accidentally, and we are not supposing this thing to have. Okay, no issue. Uh, Request handler should look like this. So we got the solution from the AI itself. Okay, but we will try on these questions. Not now, later on, because I think so. We have a solution discover here, but we can see the architecture, how it's going, and we are also correct. We have been understanding how the architecture will be because of practice sessions. The important problem we have intentionally have is there is an edge case. What happens when the user clears the input? Oh, this is the edge case, and it will be interesting. That's a problem, probably undesirable. When should probably do? Mhm. There is another subtle issue. Suppose request A is one is the apple and user clears the input. We need to make sure the request one can't come back later the populate the empty search. Okay. There is this is where your request ID becomes designs come particularly useful. We should increment the user request ID before returning. Uh-huh. Your current architecture endpoint distinct. Okay. State async render autocomplete request ID. Your turn, small implementation exercise. Don't copy the next piece from me yet. Modify handle input yourself correct handle. Okay. So we will not use their code. We will try to use our code. But okay, we are having a clear understanding what we are going to do. Mm, let's do this question as a with a free mind of and with a new session. Not in this continuing this session. We will be having this problem statement in our upcoming session. In the next sessions, we'll try to implement this too in the tomorrow session. So we are having a glimpse understanding what we are going to do in our next session, and also we have been try to understand what are the concepts we have been done and revised it. Okay, so we have these questions and we got understanding. We do the theoretical part today, and practical part will be we implementing in the next session in the tomorrow. Yeah, that's it for my time for today's session. We will meet you in the next session. Okay, good night. Radhe Radhe. Meet you soon. Let's stop the sharing first, and let's stop stream.